So a restaurant manager wants to produce 200 sets of dishes. One design costs $10 per set, while another costs $55 per set. If she wants to use her entire budget of $6,500, how much of each design should be ordered? So again, she's going to make 200 sets. So one way to kind of look at this to start with, if I was guessing, is just say 200, split it evenly among the two. So I could say she's going to make 100 at $10 per set, and she's going to do 100 at $50 per set. But the total budget has to be this 6,500. So if I do the math, does she use her entire budget? So 100 times the $10 plus the 100 times the $55, does that spin up the whole budget? Well, yeah, it does actually. So the answer would be 100 in each set. So that actually just checks out perfectly. So got off the first guess there. Who knew? So $100, $100. Now, again, if I want to do it mathematically, you can kind of see the math there is, if I want to say X is the $10 set and Y is the $55 set, we can kind of pick up on that X plus Y has to add up to 200. And then cost-wise, $10 times the number of sets of the $10 sets plus $55 times the number of $55 sets has to equal the entire budget, which is the 6,500. So notice that if I just multiply the top equation by -10, I can eliminate the x's rather easily using the addition method. So this becomes this -10x minus this 10y equals this -2,000. And then you have this 10x plus the 55y equals the 6,500. So the x's drop out, you have a 45y. And that would be what? 4,500. So let's say 6,500. Subtract 2,000. Yeah, that's 4,500. So if I divide that by 45, we do get y is equal to 100. So that's the $55 sets is 100. Remember, the total number of sets is 200. So if you go 200, take away the y, in other words, 200, take away the 100, that actually gives you the number of $10 sets, which would still be 100 there. So it would play out the same. Okay, so notice that guessing and checking can be just as effective as doing it algebraically.